is x equals y squared, and then it's x equals 1. So this is the region that you've got to figure out. And then it's telling you the line you're revolving it around. So graphically, what does that look like? Well, y squared is a lot like x squared, except it's over here. I don't know, it's kind of around the x-axis. So you got to be comfortable graphing these things, without having a calculator available. So then there's a line x equals 1, and so that it's this region in here. That's x equals 1, and it just so happens to be the same line that you're going to revolve it around. So this is actually a disk because there's no gap between the curve and that. So it's the integral pi r squared, and big R in this case is the distance from the line to the curve. Okay, but do you see how there's like a little gap there, because the function actually gives you this green part. Maybe that's not really easy to see, but it gives you that green part, and we really want the red. And so R is kind of the hardest thing to figure out here. R in this case is 1 minus y squared.
Right.
Because y squared gives you the green part, but we don't want that. We want 1 minus it.
Is pi r squared, is that the formula for a disk?
Yes.
Problems?
Yes.
Okay.
I don't know if it's K or C. I really have no idea, but it's the ones where there's no gap. The non-washers. Okay, so the bounds here, the bounds are your y bounds. So it's your y value there at the top and your y value there at the bottom. So this time it's from -1 to 1, and that point there is 1, -1, and then this one up here is 1, +1. So they're in terms of y this time, because you're integrating with respect to y also. So this equals the integral from -1 to 1 pi 1 minus y squared dy.
Okay.
And you could do all that if you wanted.
Right. Yep.
Okay, so let's just change this up just slightly here, because one of the things I don't think you're seeing here. I guess so let's say x equals y squared. We want to do x equals 0, and we want to do it about x equals -2. It's really similar to this, but it's enough different that we should talk about it. So here's your graph again of x equals y squared. It's the parabola here. Here's the line x equals 0. So it creates this kind of, I don't know what you want to call that, but let me use a different color here this time. And here, it's this region in here. But this time we're revolving it around the line x equals -2. So x equals -2 is over here. Now this time there's a gap.
Right.
So is it a disk or a washer?
This is a washer.
It's a washer. Okay, so your washer formula is integral from whatever bounds pi big R squared minus little r squared. So your big R is the distance from, so I'm trying to grab another color here. It's the distance from this here. So it's all the way to the curve. Okay, so your big R this time is y squared, because that gives you the distance to the axis, but then you have to add 2 to it because of this right here.
Okay.
And then your green, you see it in green, your green is your little r, You see how your green is the same everywhere?
Yes,
So it's always 2.
okay. It wouldn't be -2.
It's always the distance. So even though it's 2 -2,
Oh, so it's absolute value.
yes.
Okay. All right.
Is that okay? I mean, is that clear?
Yep.
Okay, because it's really kind of the same. It's a different region, but it's the same kind of stuff here. But because there's a gap, it's a washer problem. So it becomes the integral. Okay, and it's your lower bound is still this y value or this -1 to 1. And then pi, big R squared is y squared plus 2 squared minus 2 squared dy.
All right.
Any questions on that?
No, that was
More straightforward. Okay.
that was good.
All right. So let me look at this. I'm still looking at the page you sent from last night, I guess. My opinion is that the ones that are the hardest are these ones where it kind of overlaps
Yeah.
onto itself. I don't know how many of those you'll get though. So let's
I just
see.
have a quiz tomorrow over over this stuff, so it'll just be one problem.
It's one problem.
There's one problem of this. It'll probably
Okay.
be 2 problems though. Probably with the shell, maybe,
Okay.
and of just the area between the curves. There might be 3 problems. I don't know. I couldn't tell you.
Yeah, it's tough to yeah, I mean kind of guessing, but okay. Maybe look at these 7.3 shell problems or
Okay. Yep.
okay. Okay, so it says let S be the solid by rotating the region shown in the figure about the y-axis. Okay, so we're revolving it around y over here, and they want you to explain why it is awkward to do the slicing. So the reason it's awkward is that you have to find sort of this radius here, right? But then you've got kind of this other region where it's not the right color. Let's use blue, green. So they got this right here. It's not the right sort of geometry. I don't know if that makes sense. Like it doesn't. You got kind of this max. I don't know. Maybe it's not clear here why this is not a good disk problem or washer problem. So like what is a good washer problem? It's something where when you draw your radius, like you just know it. Here you've got kind of a max there. So you'd have to almost like break this up into kind of this part first.
Yeah.
And then this other part. It's a little weird. And it's all because we're going around the y-axis. If we were going around the x-axis, that's great. We just make our radius and revolve it.
Right.
So that's why this shell method comes into play here. So the shell method is the integral. Hopefully you've seen this. When you're going about the y-axis, it's 2 pi, and then I'm just going to sort of say x times the height.
Right.
Have you seen that in class?
Yeah.
Okay. Now the height, this is your height. The height is generally the y. Is that okay?
Yep.
The x it's x when you're doing the y-axis, but if you're offsetting from it, then you have to modify your x. Did you see that in class?
I don't remember hearing about
You don't
that.
remember that? Okay, let me look real quick and see if you got any problems like that, just to see if I'm even. Yeah, so we'll see that in like questions 9 through 14, maybe. Yeah, questions 3 through 7, we'll see that. Okay, but it's not always X is my point. Like
Uh,
you look at the formula and think, oh, it's always X. It's actually the distance to the line that you're revolving it around.
The two equations that she gave us were integral, or for when you're rotating around a horizontal axis,
Uh-huh.
it's integral from C to D 2 pi RH dy.
Okay. Yep.
And then for a vertical axis, same thing, but interval is from A to B.
Yeah, it's essentially the same thing as what I'm talking about here.
Okay.
You'll find my formulas are a little more intuitive to use. But if you want, we can use the ones you were given in class. You tell me.
If there's an easy way to solve them,
I just think that, so I'll try and explain this, like why this is better is it already kind of has the things that you're used to seeing. Height is the Y value, X is genuinely X, whereas R here, you have to kind of navigate what that means.
then.
And Y really does refer to a vertical axis.
Oh yeah, okay, I see what you mean. I'm looking at notes and
Okay.
right. Okay, yeah, I see what you mean.
So this is the integral from 0 to 1, because those are our bounds. Okay. 2 pi X, in this case, it's X. And then it's multiplied by X times X minus 1 squared. So this is truly your X, and then this is your height over here.
Okay.
So you generally plug these in, and then you multiply and integrate and stuff like that. Is there anything on this one you'd like me to cover in? So I was gonna do the next one also.
So is X just
It's a real X. Like it's like in this case, your R is X.
is it always X?
No.
Okay.
Well, you'll see that when we do some of these 3 through 7.
Okay.
Like sometimes it's X plus 1, sometimes it's 1 minus X.
Okay.
There's some things there. Okay. Like if we were to use this line to revolve it around, it would be a different one. It'd be 1 minus X.
Okay.
But is it clear? Like usually you take the 2 pi out. Maybe I should spend just
Right,
a tiny little time. You take the 2 pi out. It's X squared. You have to FOIL this.
Yeah, she said a lot of it's integration by parts is basically the integrals.
It could be, yeah, it could be. This one is nice though. This one actually works out where you can just do your then you multiply and you get x to the fourth minus 2x cubed plus x squared. Okay. So that one's now it's basically done because you can integrate it. So let's look at number 2, because number 2 is kind of that integration by parts that happens here.
Okay.
All right. So it says let S be the solid rotating and figure out the y-axis. Okay, and then they want you to sketch the shells. My sketching is not real good, but this is X. By the way, that's the X that they're talking about.
Okay. Yeah, right.
So this one's the integral from it's 2 pi X times H, and your H is the Y value.
Is H always the Y value?
Yes.
Okay.
When you're doing the vertical axis, when it's the other way, which we'll get to, we'll do that. So this is the integral from 0 to square root of pi, 2 pi X times sine X squared. dx. This is your height. And then your x is here.
Okay.
Now, this time, I think it's why Luke could talk about why it's preferable to slicing. And let's just even say they wanted you to revolve it around the x-axis. Like it's a totally different problem. Like this becomes the integral from 0 to square root of pi sine x squared dx, and that's a pretty tough integral. But this one on the right can be solved by use substitution.
Why does it become sine x squared?
Because it's pi r squared.
Oh, okay.
And your r is now the y.
Is that still using the shell method?
No.
Okay, that's okay.
So the point here is maybe this isn't going to covered real well in class, but like you can use the shell or the disk or washer method, and you should get the same answer.
Okay.
But sometimes you can only do one method because it's impossible to do the other. Like you just don't have enough ability to integrate it.
Right.
All right. So so on the right here, let's talk about how you would integrate this. It's u substitution. Okay, your u is x squared, your du is 2x dx. Okay, and you probably want to change your bounds. So, u of 0 is 0, u of square root of pi is square root of pi squared. So it's just pi. So it becomes the integral from 0 to pi, 2 pi x sine u, and then instead of dx, it's du over 2x. And you get some nice cancellations here. The 2's cancel, the x's cancel, you get pi sine u du. And then the antiderivative of sine is minus cosine. So this is minus pi cosine u evaluated from 0 to pi. And so minus pi cosine pi minus cosine 0. So this becomes minus 1, minus 1. So that's minus 2, so it becomes 2 pi.
Could you do integration by parts with that problem?
It's not necessary. No.
Okay.
Yeah, it would create more problems if you do that.
Oh, okay.
Yeah. So it's a little, it's some ways, hopefully your integration isn't that tough, but you have no way to know until you get in there and start doing it. Okay, let's look at, let's just do 4. I guess we'll do some of the evens.
Okay, that's fine.
And you can tell me if you want to do some of the other ones.
I don't know which ones would be like good examples.
Yeah, there's so you're getting to the point where there's so many, it's hard to be like, oh yeah, it's one of these. You I don't know. But you got to be able to graph these things. So y equals x cubed, y equals 0, x equals 1, x equals 2. So they're trying to show you the what this region looks like. So here's x cubed. X cubed is at has some points of 1, 1, and then 2 is at 8. So 2 8s at 1, 2, 3, 4, 5, 6, 7. Right there. So the curve looks like that, and we're bounded it by 1 and 2 and 0. So it's this right here, and we're revolving it around that. Is that okay?
Yep.
Okay, so this one's got a block here. Do you see that? It's kind of not great. So you really have 2 regions. You have region 1 and you have this other region here, region 2. You can't do them together.
Oh, okay.
So the first one is 2 pi x h, and your h in this first one is the height of this block right here.
Mhm.
So it's 1. And the limits of integration are the y values. So you're going from 0 to 1 because you're 0 to 1, your height is 1.
Uh-huh.
I'm sorry. No, I'm sorry. It's I misspoke there. The limits of integration are from 1 to 2 because that's your x-axis. Whenever you do an integral in dx, your limits are on the x-axis.
Oh, okay.
Sorry, that's really wrong. So this becomes the integral from 1 to 2 pi. It is x, okay, because x, it's the distance there, and then your height is always 1. So this is that first region. The second region is from 1 to 2 also, 2 pi, okay, x, but this time your height is the y value. So your y value is this x cubed. The problem is though, is the x cubed gives you the whole height, and you can't do it with this. You've got to like deal with the fact that you've already got you've already had this other chunk dealt with, so you end up subtracting 1 from it.
Okay.
If this was x equals 0 to x equals 2, you would just do the 1 integral because it would be nice and smooth and
Uh-huh.
in that area. But like this is a little bit awkward. Okay. So there you have it. You have to do integral 1, and then you have to do integral 2, and then you get your final answer.
Do you add them?
Yes.
Okay.
So there's a big plus, big plus.
All right.
Okay, so now let's look at 6. All right, so y equals 4x minus x squared, and then y equals x. So they don't even they don't give you anything more than this. You actually need to figure out where these intersect. Are you allowed to use a graphing calculator on this? Okay, so you got to set them equal to each other. 4x minus
Right.
x squared equals x. And let's see here. So you would subtract x to the other side. You get 3x minus x squared. You factor in x, you get 3 minus x. So at x equals 0 and x equals 3. Trying to think like, why does that even work? Okay, so your graph, and this, you'll probably be asked to graph one of these, is this line y equals x. That's the easier one to do. That looks like that. And then this other one, I don't know exactly what it looks like, but it hits right there.
Okay.
So it's this region right here. So your height this time, this is your height. That's your height.
Right.
So this is 4x minus x squared minus x, which is 3x minus x squared. That's your height.
Okay.
Okay, now your integral is from the 0 to 3, because those are the bounds there, 2 pi. Now this time it legitimately is x because it's the distance from there, and we're going around the y-axis, so it's always x when it's the y-axis. But then your height though is 3x minus x squared dx.
Okay.
Okay, so probably we should just move right to 9 through 14. They're the harder ones. They're the ones that
Okay.
are about the x-axis. So
Alrighty.
we'll just do a bunch of these to hopefully make it
Okay.
clear.
That works.
Okay, so your graph is x, y equals 1, x equals 0, y equals 1, y equals 3. But they tell you in the instructions, which you may or may not have, that they tell you that you're gonna do about the x-axis. So now everything's switched. So you really want this in terms of x. So x is 1 over y. But if that's hard to graph, you can still graph it as 1 over x. They produce the same graph.
Okay.
So the graph of 1 over x, and most of the time you're in the first quadrant. Thank goodness. The 1 over x kind of looks like this. Let's go y equals 1.
So when you're rotating around the x-axis,
Uh-huh.
when you're doing shells, you want to have it in terms of y.
Yes. When we're
Okay.
running around this axis. And that's why you would never, like if your instructor just said
Makes sense.
define the volume of revolving around the x-axis, you would choose to use washer method rather than shells, because you can just keep it in terms of x, and you're much
Okay.
better at that. You know, everyone is.
Okay.
Okay, so there's a point up here. This point right here is 1/3, 3. How did I know that? Well, if y is 3, to make 1, x is 1/3, and that point is really critical. And this point right here is 1, 1. So if you remember that 1 over x looks like that, it's bounded by x equals 0, y equals 1. So it's all of this region in here.
All right.
Okay, so the integral is the integral 2 pi, and this time I'm going to put y in quotes, height, and the height's kind of in quotes too. Everything's kind of different now. So the height, this time the height, instead of height being top minus bottom, it's right minus left. So in this case, your right is 1 over y, and your left is 0.
So just rotating over the x-axis is just weird.
Yes, everything's backwards. You don't want one of these, but you probably get one.
Yeah.
Okay, so your y is actually the y in this case. It's the distance to it. So your y actually is y this time.
Okay.
Um,
You wouldn't subtract anything from y since there's a okay.
No, you because it's the distance to the axis that you're revolving around.
Okay.
So if we were revolving around this line, then you would add 1.
Okay. Oh, okay.
So it's integral from 1 to 3, because we care about the y values now. 2 pi y, and then your height is 1 over y dy.
And then could you just cancel those out?
Yes.
Okay. Easy enough.
The hard part again is setting these up.
Right.
Like the integration isn't the hardest part, because and they try to like ease up on it a little bit, but you know, you should be comfortable trying to do
Okay.
it to do the integration. You should be happy when you get there because you're done with the shells.
Right.
All right, so let's look at another problem here. So this time it's y equals square root of x, and then this is kind of important here. So sometimes you just draw the line. So y equals 2 is here. Square root of x goes through 4, 2. So I'm setting these equal. I'm saying, where is the square root of x equal to 2 when x equals 4? And that helps you to identify these these points. So this is the region. Okay. And I'll shade it in red. Again. Okay. So you're doing it around the x-axis again. Notice if you're doing it around the y, it wouldn't be that bad either, but it's about the x-axis. So this first one needs to be solved for y. I'm sorry, for x, because you're doing everything in terms of y in your integral. And that's another thing you're going to see is you'll have to be comfortable switching between them.
Yeah. All right.
All right. So the bounds of the integral are your y bounds. So from 0 to 2 pi, and your y is genuinely y because it's the distance from the x-axis. It only gets weird when you have an offset. So it's y. Your height is right minus left. Your right is this curve right here, which is y squared minus 0.
So do you always do right minus left with the?
Yeah.
Okay.
Whenever you're trying to figure out the y stuff, it's right minus left.
All right. Oh.
So then you dy. So then you integrate. Okay. Move on to 11.
Yeah, that's fine with me.
Okay. All right, y equals x cubed, y equals 8. You try to stay in the x as long as possible. So y equals 8, 1, 2, 3, 4, 5, 6, 7, 8. That's up here. So at 2, there's this point 2, 8. You set these equal to each other. X cubed equals 8, x equals 2. And then x equals 0 is down here. So we know that the cubic thing looks like this roughly. And we've got this line right here, and we've got x equals 0. So it's all of this region right here.
All right.
Back when we're doing zooms and stuff, I would actually hold up the paper and you could actually rotate it to kind of see how this would look on the X. There is some help there, but when you do a few of these, you start seeing the pattern here. So you're going around the X. So it's the integral from 0 to 8, your y bounds, 2 pi. It's y because it's distance with the x-axis. But your height this time, your height is right minus left. The problem is this is in the wrong. It's not solved for x. We're going to solve for x. X is y to the 1/3 power. So it's y to the 1/3 power minus, in this case, 0, because the axis is 0.
Okay.
dy. I guess the more I think about this, if I were giving a quiz, I would probably ask you to set it up, not to actually integrate it.
Yeah, she said she'll do both, but I don't think she'll make us integrate it at first.
Okay.
Hopefully not.
Yeah.
Or actually, no, it's not even that bad.
It's not that bad, but that just because you want to give variety of questions here. All right, so number 12. Number 12 here. X equals 4y squared minus y cubed. So I mean, I have no idea what this looks like, and x equals 0, but we can factor out a y squared and get 4 minus y. And that tells you that it's 0 when y equals 0 or y equals 4. And you kind of have to use some of those skills to be able to answer this. So here's 4. So we don't know where it goes, but it looks something like that. And there's x equals 0. And if you're not sure about any of these, like, use Desmos, use something to like confirm that you've got the right graph. Okay, so the integral here, you're using your y bounds 0 to 4, 0 to 4. And then it's 2 pi y, because you're going about this axis again. Your height is right minus left. This one is solved for x. Okay, so we already have it there. It's 4y squared minus y cubed. And you've seen me like subtracting 0. I mean, you don't have to keep doing that if you don't want to. Okay, so let's move to 15 to 20.
Okay.
Yeah, my guess is that the harder ones are the ones where it's an x equals, because you're, well, no, I guess that's not true. It's the y equals, because then you're doing it in terms of y. But let me just grab an even here and see if we can make some sense of this. So I was thinking about doing 16, I guess.
Okay.
All right, so y equals square root of x, y equals 0, x equals 1. So we're looking at something like this. 1, 1, y equals 0, x is, okay, so we're looking at this. I'm sorry, that's not real big, but that is 1, that's 0, so it's this region in here. Let me not do it in that color. But this time we're revolving it around the line x equals -1. So this is a vertical axis. And when it's a vertical axis, it's 2 pi x h dx. So this time we're integrating from 0 to 1. Your x this time, though, it's not x. Your x is x, but you have to add 1 to it. So it's x plus 1.
Okay.
Your height is top minus bottom. Well, your top is square root of x. Your bottom is 0. So it's square root of x minus 0. If you want to do that, top minus bottom. And your limits of integration are always that kind of whatever that area is enclosed by, not, it has nothing to do with this other number.
Or why is it top minus bottom this time?
Because with the height this time, so the oh boy, let me just make a little bigger picture here of this, so you can do it a different way. So I'm going to blow this up and put it down here. So the height is this green. That's your height.
Right.
So it's top minus bottom because it's an x integral. So it's the square root of x minus 0, because 0 is down here.
Okay.
But the x is really, this is x, that's x right there. But then there's always this plus 1 that goes along with it.
We're rotating around that line, right?
Yes.
Okay.
So it's a vertical axis. Okay, I'm gonna go right to 20, I guess, because It's I guess we'll do 19. I want to make sure we get a couple of these other ones.
Okay.
Y equals 1. Okay, so we got y equals x cubed, y equals 0, x equals 1. So I guess I got to zoom in on this a little bit more. So let's assume that this is 1, 1 here. So that's 1, that's 1. So y equals 0 looks like this, x equals 1 looks like this, and then x cubed, it's got this kind of shape to it right there. So we're taking that region, but this time we're revolving it around the line y equals 1. So because this is a horizontal axis, we're doing it in terms of y. It's the integral 2 pi y. And then it's your height. Your height this time is right minus left.
Right. Okay.
dy. Okay. So your bounds here, those are those, do as much as you can is 0 to 1, because that's 0 and that's 1, 0 to 1. Great. 2 pi. Now it's not y, okay, because you're not revolving around the x-axis.
All right.
It's 1 minus y, because the distance to this line changes, where, and sometimes you got to check the endpoints. Like it's either y minus 1 or it's 1 minus y. So which one is it? Well, when y is 0, it's a 1. So see how this one doesn't work for that?
Uh-huh.
And when y is 1, it's 0. Now, and then this one does work. So that's one way to do it. You can also think of it as like, if there's a gap that's positively contributing to it, you add, but if it's a gap that's negatively contributing to it, you subtract.
Okay.
And then your height is this right minus left. Problem is though, is that it has to be in terms of x. So x is equal to y to the 1/3. This is y to the 1/3. But what about this over here? Well, this is x equals 1. So it's 1 minus y to the 1/3. Because that's your right. Your right is 1, your left is y to the 1/3.
Could you draw a line that represents the height?
Yeah, the height is, so we're doing green. This is your height right there.
Okay. And that's because you're rotating over a horizontal line.
Yes. It's all backwards. Yeah, I mean, if you had time, you would chart it out, like make different quadrants in the paper for x-axis, y-axis. What's the height? What's the radius?
Yeah.
Okay. Do you think you're going to get a calculator problem?
No, we don't use calculators at all.
Okay, so one of the pages you sent me was, set up an integral for calculator. So you can maybe ignore those on your review. Okay, let's try to set up 20. All right, so I'm gonna snip 20 in. Okay, so this it's already solved for x, that's good. So you need to set these equal, it's wrong color. Set this equal to this, so y squared plus 1 equals 2. You'll find that y equals plus or minus 1 when you do that. So that's important because you gotta kind of get an idea of what the shape is. So x equals 2 is this line right here. Y squared plus 1 actually looks like this parabola right here. And that's how I knew it hit at 1 and minus 1, but it's this region in red. And this step is not to be overlooked. Like you might want to spend a little time just playing with Desmos or graphing it by hand on your calculator. You still got one now to figure that out. So now we're doing it about the line y equals -2. So that's down here. So since it's a horizontal axis, it's a y integral. So that's integral from -1 to 1, 2 pi y, and we're going to figure that out. And then your height is right minus left, and dy. So this time it's not y. Your y is the distance to here, to this line. So your y, you
Yeah.
have to add 2 to it,
Okay.
because there's a distance of 2 there.
Okay.
Your height is right minus left. It's 2 minus parentheses y squared plus 1. Because that's your right, your left is this curve here. And then you integrate it.
All righty.
Okay, try to work through these examples
Okay.
on your own. Try to do the best you can to organize your thinking, but try to do them in groups, like do a bunch of x-axis, do a bunch of y-axis in a row. That way you kind of see the
Okay.
pattern. Don't try to mix them up yet. You'll just confuse yourself.
Okay.
Cool. Well, thank you so much for scheduling, and good luck. I'm sure you'll do great, and I'll see you next time.
All right. See you.
Have a great night. Bye now.